Hello there, it's some performance characteristics again, and we're looking at papers and boards. I will try and make this as engaging as possible and make sure I can highlight the key things to remember, and like I say, with the help of some images, kind of help just explain what's going on. As always, there will be some little slides that tell you what to do when to complete some activities. A link to the worksheets uploaded to the Google Classroom, so you should be filling out the worksheets whilst you're watching these videos. It's like a lesson, but not in school. Obviously, you can't ask me any questions, but if you've got any questions throughout this, feel free to ask me in the lesson, or just Google it and find out for yourself. But like I said, it's best to fill out these worksheets as you go through the slides, so it's fresh in memory, and you can always pause and kind of rewind the video if you're stuck, or if you can't remember something. So, objectives: to understand the common sources and manufacturing process of papers and boards, the stock forms, and identify specific qualities for a selection of papers and boards. What is it made from? So both paper and board are made from cellulose fibres derived from plants. The fibres pictured are from waste sugar cane that has had the sweet juice extracted from the sugar for sugar. The shredded cane, named bagasse, is processed to make popular paper products. What other sources of cellulose fibre are used for paper and board products? Have a little think about that. Paper and board sources. So sources of cellulose fibres include flax, hemp, straw, cotton, bamboo, and most commonly wood, of course, trees, natural trees, timber, what am I talking about? Trees. Also papyrus, if you want to get go back in time a bit, back to the Egyptians that used that kind of reeds that grew to make paper, for the very first forms of paper. Are special trees needed? The best cellulose fibres for paper production comes from wood due to quality of the fibre's length and strength. Obviously this adds to deforestation, but a common misconception that is the reason for deforestation. Most trees are cut down illegally or illegal logging to make room for cattle grazing and feeding, and for planting palm oil. So it's not all due to making paper, but it certainly contributes towards it. Softwoods are the more common trees used for this. So it's made in a big vat, basically like porridge. As you can see in this picture, it looks just like porridge, and it's debarked chipped wood mixed with acid to bleach it. Filters like clay and calcium carbonate are often added. Brightening agents such as bleach, let's make it white. And finally, lots and lots of water. Wood-free pulp. So the solution is heated to 140 degrees Celsius, which produces a fibrous liquid known as pulp. Dyes and sizes can also be added to the pulp depending on the desired final appearance. Obviously, most paper is white, so it's bleached to get that white finish. It obviously is not. It's kind of like a sludgy, brown, porridgey appearance before it's dyed. It takes a minimum of 500 millilitres of water to make one A4 sheet of photocopy paper, which is about that much water, quite a big bottle there. So loads of water are used in the process. Nearly all of this water is filtered and reused, which is good. After it's cooked, the thick paste is cooked. After the cooking process, the remaining fibres are called wood-free pulp. So how much is needed to make a ream of photocopy paper? There's 500 sheets. Bit of maths there. If you want to bother with that. What are paper qualities? So again, you need to think about what its use is. If you're an architect and you want to be able to see through it, or if you are sketching and you don't want the end of your pencil to snap, or you don't want the paper to tear, you need to think about all of this kind of stuff. So whiteness, how bright it is, opacity or translucency. Strength, absorbency. Again, you've got to think about if you're using kitchen roll, it's got to be absorbent. If it's not, it's pointless, it's rubbish. Finish, how it looks, matte. Think about posters, think about glossy magazine pages. Cost, and then which properties affect printability. So a lot of them do obviously affect printability, especially if the ink's bleeding and all that kind of stuff. Creating the perfect paper. So the 5 ingredients that can be tweaked are the source of the cellulose fibres, obviously where they come from, plant or tree. The fillers that smooth out the finish of the paper. The sizing agents that increase absorbency. And the calendaring process. So that's obviously it being rolled, all the water squeezed out the paper, and obviously it's quashed into its specific thickness. That can obviously affect it. And then any additional finishes like UV varnish or texturing if it's kind of packaging or takeaway food, cardboard or magazine pages or newspaper, all that to think about. What stage uses chalk? So obviously that is going to be used as like a filler if it's going to be white paper. Sizing reduces absorbency. So sizing agents are chemicals added to the pulp or sprayed and rolled to the base paper. Internal is added to the pulp and affects paper quality. And the paper's ability to run smoothly through the machines with calendaring. And surface sizing is added to improve strength, reduce absorbency, and hence provides printability. So you've got to finely balance all of these properties between them to kind of get that perfect paper. Do you want it to print well? Do you want it to be glossy? Do you want it to be easy to copy onto? Do you want it to be able to sketch on it easily? Do you want to be able to paint on it with watercolours? And all of this kind of stuff you need to think about. Coating finishes. So the application of surface sizing is the main difference between coated and uncoated stock. Coated paper reduces ink absorption, which results in brighter, richer and sharper images with deeper blacks. So if you're doing magazine front covers, posters, stuff like that. There are 2 main coatings, clay, which makes it smoother, and a plastic, which is polyethylene or PE, which increases its gloss and wet strength. Obviously implications there about recycling. You can't recycle paper or board that's been coated with plastic. Unfortunately, a lot of wrapping paper can't be recycled when you put it in the recycling bin because it's got kind of a plastic coating on top of it. Uncoated paper, there's a nice napkin there. Uncoated paper is not treated with any sealant. This grows greater and faster absorption of water or ink. So kitchen roll being a good example. As printing ink is applied, it goes deeper into the paper rather than drying on the surface. So if you've ever kind of stuck a fountain pen onto some toilet paper or kitchen roll, it will just kind of sink and kind of drain deep into the paper. The result is that colours appear dull and the paper is weaker compared to coated paper. So, tearing a napkin in half is no problemo because it has not been finished or strengthened, no plastic finish on it. And obviously its absorbency is very good, which is what you want. The benefits are that it can give a wide range of textured finishes. This is going to be in this embossed feature on here. Paper and board finishes, so you obviously get matte, which is a kind of that smooth, dull in appearance, not very reflective, not very shiny, not very glossy. Which is good for any high quality print job because obviously the colours stick very nicely to it. Satin, which is not quite gloss but still more reflective than matte. And gloss, which is the shiniest, just like a magazine. If you think about magazine covers, glossy. And textures are created with a felt roller covered in woven wire. Felt woven vellum are increasingly smooth textures, whereas column, linen and laid have lines at different depths and positions. There we go. Strength factors. So tear resistance depends on 4 factors. How they're bonded together, the strength of the fibres themselves, the length of the fibres, obviously the longer they are, the stronger they are, and the quantity of fillers used. So obviously that filler that is added to increase the strength of that paper. So there's just normal bit of kind of a paper there that you might find in school, copier paper being torn quite easily. If you've ever tried to tear photo paper, it's very, very difficult because of the kind of gloss plastic coating it's got on it. Obviously you can do a test for everything. You can do kind of like hardness, strength, ductility testing, and with papers and boards you can do tear resistance testing. It's the Elmendorf tear test. It's the most widely used for paper and board. Who knew? And it calculates how much force is used to continue a tear of a sample, so continuous tearing of a sample. Samples are partially cut and clamped in position, and a pendulum tears the sample and continues to a resting point, which is noted on a scale on the left in Elmendorf units. There you go. The Smithers Pirrer test is similar, and measures multiple sheets. But you don't really need to worry about that. You just need to be aware there are different ways of testing these different properties of materials. So there you go, the Elmendorf test. And yeah, clamp the paper, tears it, and obviously where it goes to on the scale depends on how easy or not so easy it is to tear. Impact resistance. So another way to measure the strength of paper and board products is to subject them to an impact force. The main ways paper and boards are damaged through impact are packaging being thrown about, smashed, damaged. Think about Amazon packaging with the corrugated cardboard. And indentation through use of implement on the surface, such as a pencil or a pen. So a very sharp pencil, if you're using the rubber in it and it kind of rips. Things to think about for textbooks and textbooks in schools, obviously. So obviously every material we use has got to be fit for purpose, and paper qualities are usually considered depending on their end use, obviously. So the paper's weight. Something that not many people think about is weight. Obviously you've got to think about things are being delivered around the world or being packaged and kind of put in lorries and shipping containers. The heavier something is, the more expensive it is to ship, but also the bigger impact it has on the environment, because the lorry is going to be creating more CO2 if it's got a heavier load, etc., etc. Longevity. How long is the print going to last on it? Is it going to get worn off easily? Impact strength. So corrugated board for packaging. It's reinforced and structurally strong, which is why it's perfect. And obviously it's very light, because there's a lot of air that fits between the corrugations and the gaps, so it's very light to kind of transport around. And obviously waste and cost efficiency. So does the design fit or tessellate on the stock sizes? Can you get it in those stock sizes as well? So die cutting is the most, the kind of the biggest commercial process that you'll need to know about for working with papers and boards. And it's a way that can be cut, scored, perforated and creased in one action with a die cutter, using kind of very thin, sharp pieces of metal that can be pressed into the surface of the paper board. And it's a way of getting large quantities of identical shapes. And it's made from kind of plywood backing plates, and it's skilled technicians using CAD drawing and the lathe cutter. Nets for packaging and stationery products are made this way. So you can see how it works. So obviously cutting blade over here, that's basically how it works, attached to a plywood block, and then it's pressed into the material, and it can be cut, or over here it could have a creaser, dependent on whether it's creasing or cutting, and obviously that puts a crease into it. So it's a very simple process. It's basically pressing different bits of metal, whether it's sharp or kind of blunt, to create those creases or those cuts or folds. So folding and creasing, very similar way of kind of putting a mark into origami. So these little rabbits have been kind of folded and creased. But a folding is kind of made to create a box. It's more kind of used in industry, and creasing is something that you might do to permanently kind of bend paper if you working with origami. And they become permanently crushed, basically, because you're putting a lot of force through the edge of that bit of paper, and it weakens it, which allows you to then form it into shapes like this. But yeah, you can't get rid of a piece of paper. There's a assembly that a lot of head of years do, where they get the students to kind of fold up a bit of paper or crush it in their hands, and they say, right, try and get those creases out, and you can't. And it's basically saying that if you're mean to someone or you've got any nasty things to say to them, they don't go away, they don't forget them. You can't get rid of those creases in that bit of paper. It's just there forever. Scoring is when you're using a blade as opposed to creasing and folding, and you want to kind of permanently cut, but not all the way through, kind of halfway through the thickness or third way through, to get a very, very, very neat kind of fold. Score lines partially cut the material, allowing a sharp edge or join to be created much sharper and much finer than a crease or a fold. Then we've got perforations. Looking at this stamp here and this little perforating wheel, kind of little gadget, and you just press hard. It's quite sharp, and it obviously just cuts this kind of zigzag shape around the edge. So it's quite good for for decoration and good for peeling off things like that. So allow for just portions of it to be folded or torn, and usually created with a perforation rule in a die cutter. So just like the die cutter would cut or crease, it could also perforate. Great for if you've been given something like a gig ticket, and at the door you have to pull it apart, or the bouncer just tears off a bit of a ticket stub for you to keep. So it's a way of kind of joining it and then temporarily being able to and then rip it off. So yeah, gig tickets, stuff like that if you're going into a club. Not used as much now because we obviously have apps and everything stored on our phone, but still something you need to know about. In school, obviously, you'll use safety mats or craft mats or cutting boards, and then we've got safety rules. So this is a steel rule. Safety rules have a little a fold in the top to put your fingers in, like a little channel, so that you don't risk cutting the ends of your fingers off. This is just a steel rule. And then obviously we use scalpels or craft knife or Stanley knife to cut through cardboard. And obviously you'd use the blunt edge of a knife or the back of it if you were scoring or getting a fold. Obviously you can use a laser cutter to create nets, and you can obviously ask it to engrave, which is really, really useful in school. So just at the end now, so for a plenary, you're supposed to think as you've completed your worksheet, hopefully. Why are cellulose fibres needed in the production of papers and boards? Why might bleaching agents be added to the pulp? It's quite an easy one. What is the process used to decrease the absorbency of papers and boards? We've covered that already. And die cutting cuts paper and board. What other processes can it perform? So again, as we've already covered, it's not just used to cut. It can be used to kind of crease, fold and score. Lovely stuff. Right, thank you for joining me.